Okay, we are making our way through this article and we are close to getting to the results finally after kind of having talked about just the literature review, the material and methods, and what each of those stages is involved and how they tested for reliability, validity. We left off at effect size because for responsiveness, they used effect size as the measure. Now, in statistics, we usually do one or two things. We're either going to look at we're either going to focus on the hypothesis and say, do we accept the hypothesis, null hypothesis, or do we reject the null hypothesis? And from in that standpoint, we're looking at statistical significance. And essentially what we're trying to say is, does it work or does it not work? And we generally base it off the p-value. If it has a low p-value, then we'll say it is statistically significant. If it has a high p-value, then we say no, it is not statistically significant, so therefore we failed to reject the null hypothesis. The other aspect of what we do is we look at the effect size. So again, when we look at statistical significance, we're simply asking, does it work or not? Did that intervention work or not? Did that therapy work or not? But with effect size, it's a little more sophisticated because we're asking, how well does it work? Okay, so effect size is essentially the magnitude or the size of effect. It's a way of quantifying the size of the difference between two groups or two variables. How much change is there? Okay. It allows us to just kind of move, like I said, beyond the does it work or doesn't work. And again, allows us to see how well does it work. And more so by placing the emphasis on the important aspect of the intervention, the size of the effect, right? Rather than just the statistical significance. Because sometimes the statistical significance can conflict effect size and sample size. So it promotes a more scientific approach to the accumulation of knowledge, okay? And therefore, that's a lot of the reason why we report it. The routine use of effect sizes have generally been limited to meta-analysis when comparing estimates for different studies. But it also gets used in different ways. So you'll see it a lot again within meta-analysis, but in this case, because we're looking at how more effective the ULFI is compared to the DASH and compared to the UFS, we're comparing the effect size between these outcome measures. We're going to use effect size here to measure responsiveness. Now, I am going to go more into effect size, but I just wanted to give you the basic overview. So effect size, again, looks at the magnitude or the size of the change. How much more effective is something? Or how much more is, what's the more effectiveness between the groups? Okay? All right. That's just the basic explanation of what effect size is. We'll go back to it as we go towards the graphs and the charts and the tables. Okay. Woo! Now, after kind of talking about all of that, let's just go ahead and take a look at the results. So, starting with the results, they tell you the study sample and they just kind of break it down. So, they provided 214 responses from 139 subjects for both the ULFI and the DASH, with 9 subjects and their responses being excluded, providing a final total of 205 responses from 130 subjects. The UFS had 64 responses from 32 subjects, with 1 subject and his or her responses excluded, to provide a total of 62 responses from 31 subjects. So, this says revert to table 1, so we can kind of go back and look at table 1. Table 1, again, was just the overview of the data collected for the 3 outcome measures, the number of responses collected, and the number of patients. So total number of patients or subjects looked at within this study was 139. Total responses were 214. They did a test-retest for the ULFI and the DASH, but not the UEFS. They did in the main study for test-retest, they did do that they looked at it for all three. So the ULFI, the DASH, the UEFS. For responsiveness, they were only able to test it for the ULFI and the DASH due to there needing to be a change in score. And additional patients for comparison were only looked at for the ULFI and the DASH. Now that's just a little review of Table 1. Now we can go back down Table 1, so you know where I was. That was page 331. Now let's go back down to where we were starting to talk about the results of the study, which is on page 334, and we can look down at Table 2. Table 2 is the subject demographics. So here are your descriptive statistics. Again, the total patients looked at for the study was 139, and this is just an overview of the subject and what they looked at: age, gender, employer, conditions. Okay, so let's keep going. Oh, wait, maybe make sure I didn't miss anything that was worth talking about. Okay, data distribution. I'm sorry. Let's stay on page 334 and let's talk about data distribution. All right, so for data distribution, they have noted that it demonstrated substantial variance in all values for the three self-reporting outcome measures. The DASH and the UEFS demonstrated a floor response for one subject, but no ceiling response. Just as a reminder, floor and ceiling means that it's either too easy or too hard. So we don't want those. And they're saying that was achieved for one subject. So they demonstrated a floor response for one subject, but no ceiling effects, ceiling response based on the floor effect or ceiling effect. The ULFI demonstrated a floor response for three subjects. So three subjects experienced or demonstrated a floor response, and ceiling response for one subject. So maximum scores, now they're just telling you what those scores were. 84.5% for the DASH, 73.7% for the UFS, and 100% or ceiling for the ULFI. That's what they determined for maximum scores. We'll go take a look at that in figure 2 in just a second. The ULFI and the DASH demonstrated relatively normal distribution. Normal meaning the bell-shaped curve. For the data pool, the subjects, as well as for the categories of proximal, central, and general upper extremity injuries. The UEFS demonstrated relatively normal distribution for the central category, but was inconsistent in distribution in other subcategories for the pooled data. No tool demonstrated a normalized distribution for the distal region, though the ULFI and the DASH showed tendency toward this. Okay, let me go back up. Though the ULFI and DASH showed a tendency toward this, and we'll take a look at that in figure 5. Okay, so let's take a look at figure 2 since it's right here. Now, if we go back up to page 334 in the results, they're talking about the maximum scores achieved for responses for all three outcome measures. And here is where they report that information. Okay, in each category, because they looked at 10 categories. Now I'm going to keep going. The DASH and the UEFS pool data demonstrated a skewed tendency toward lower scores, reflecting lower levels of impairment and a limitation on the degree of maximal measurement capacity. The ULFI showed no skewed tendency in measurements in all the categories. That's good. The DASH consistently measured less than the ULFI, okay, with a maximum capacity in the 8th category in all subgroups except central, which was at the 7th, and the ULFI measuring respectively in the 8th and 9th category. So for responsiveness, the ULFI measured better. The DASH measured under that each time. Now, test retest reliability that was looked at. Test retest reliability was assessed for all 3 SROMs from subjects who reported no change in their functional status between the test dates. And remember, intra-class correlation was used to test retest reliability. So here they are now with the scores. So where the ICC with a two-sided 95% confidence interval is 0.98 for the DASH, 0.96 for the ULFI, and 0.92 for the UEFS. Okay? So for test retest reliability, using the intra-class correlation, they determined that for the DASH, the intra-class correlation was 0.98. For the ULFI, the intra-class correlation was 0.96. And for the UEFS, the intra-class correlation was 0.92. Now, what do those scores mean? Let's talk about that. Let's go ahead and pull up the PowerPoint again where we talk a little bit about intra-class correlation. Now, again, intra-class correlation measures the reliabilities of ratings or measurements of data collected from groups, and it's used for inter-rater reliability. So this is another version of like the Pearson's correlation, which we talked about, which correlation looks at the relationship. So it kind of follows the same scale when we talked about the Pearson's correlation. As far as 0 means there's no relationship between the variables, a -1 is a negative relationship, and a 1 means a positive relationship. For the intra-class correlation, it kind of follows the same 0 to 1 rule. A high intra-class correlation close to 1 indicates high similarity between values from the same group, while a low intra-class correlation close to 0 means that the values from the same group are not similar. So in this case, the scores that they got with 0.98 for the DASH, 0.96 for the ULFI, and 0.92 for the UFS, those numbers are closer to 1. So that means there's a high similarity between the values from the same group. That's a good thing. Those scores are high. Now that is shown in table 3. So for every time generally that they're providing you with the word by word explanation, they're going to give you a chart or a graph or a table. So let's go down to table 3. So page 335, where they talk about test retest reliability, the actual scores that they got using the intra-class correlation, they presented it down in a graph version on page 336, so where you can see change between first and second test. Okay, the number of subjects that they used, and here's the DASH, the ULFI, and the UEFS. Here's where they're providing those same values, so they're just giving it to you in a graph chart version for you to see, or a table version for you to see. And again, that's based off a confidence interval. The higher, the closer the 1, or I'm sorry, let me rephrase that so it makes sense. The closer to 1 that the scores are indicates high similarity between values from the same group. If it's a low score, so closer to 0, that means that they're not similar. Okay? Let's go up. And as they do for all stats or all areas that are being tested, like test retest reliability, here they're providing you with the measurement error that they determined as well. And again, that's based off the Z table. So for every true value, we need to know how much error is allowed before the test is considered invalid. So those true values should fit within that range, but they have to measure what they will consider error, and they based it off again. They used the standard error measurement of a 95% confidence interval, and they measured it based on the MDC, so minimally detectable change of 90%, and they also measured it of an MDC, so minimally detectable change of 95% confidence interval. Okay, so all of this information is just for test retest reliability.